Let's play Code Wars. So the name of the kata, which is a level at Code Wars, is called Cat Yes, Dog Yes. And the instructions read as follows. So I have a cat and dog. Well, this is one of those elementary school questions again. Elementary school math question kind of things. So we are given a story. I got them at the same time as kitten puppy, and that was human years ago. Okay, return their respective ages now as human years, cat years, and dog years. So note, human years is greater or equal to 1, and human years are whole numbers only. Okay? So cat years are, excuse me, 15 cat years for the first year, 9 cat years for the second year, and 4 cat years for each year after that. And dog years start with 15 dog years for the first year, 9 for the second year, and 5 dog years for the year after that. Okay, we even have references. Beautiful. So, excuse me, your code here. So we should be returning a tuple of 3 values. And the first would be the human years. Well, that's easy to implement. We'll just return the human years here. So if we pass in 1, we'll get 1. If we pass in 10, we get 10, right? So then we should implement something that adds up these numbers as they go. So we should probably loop a number of years times. I'm thinking aloud. And then we could take the index of that loop and check against a table of years to like human years to cat or dog years, and return the value from there. That could be one solution. Or simply put, well, let's see where we get it. So the return value was to have human years, cat years, dog years, right? So let's return cat years from this, and then dog years. Like that. So then we should implement these 2 functions. So cat years would be a function that takes in a number of human years, right? And then I'm thinking about doing this Lisp style. So with recursion. Let's see how that would go. So a common Lisp-ig recursion style would be that we start with the terminal, is it a termination clause or something like that? So kind of where we end at. So if the human years is 0, right? That's our final destination where the loop ends. So then we return 0. So 0 human years will be 0 cat years. If the human years is equal to 1, we return what was it? we are doing cat years, so 15 for the first year. So 15 plus cat years. Well, basically we can start like, I don't know if we're going to implement the 0th case, but let's have that there just to be sure. So we can do it actually, well, we didn't need to consider negative numbers. So, and human years should be greater or equal to 1. So let's not consider that then. So human years is 1, that's our terminal illness cause. Terminal illness, the termination point of this recursion. Okay, and there we return 15. So then if the human years is 2, we would return 9 plus, and here's the recursion, so cat years human years plus, minus 1. So we are decrementing. And otherwise, if it's not 1 or 2, we will return 4 plus cat years, human years minus 1. So let's say we have 10 as the human years first, then it will return 4 plus cat years of 9. This will be 9, so it will do the 4 plus the next iteration all the way until it's 2, when it will return the 9 plus cat years, human years minus 1, which is 1 human year, so that's 15. So these should already work. And if you have ever done Lisp, so for example closure, I think this kind of way of thinking is pretty common in those circles. So with dog years we are going to do 5, but otherwise the same, right? So 15, 9, and then 5. Okay, let's see how we did. Okay, 10 expected 10, 56, 57 to equal 10, 56, 64. Okay, weird. So 56, 57. Okay. Oh, copy paste error. I had the cat years there. So happens for the best of us. Now it passed. Let's attempt. All the tests pass, and let's submit our final results. Okay, let's have a quick look at how others did in this kata. So this is kind of the combined version. So it's first subtracts the minus 2. Oh, so it has kind of a lookup table for the first 2 answers. So these are hard-coded. This is of course efficient because you're not doing calculations. You're just returning the static values, which may be really good because this is a function that doesn't have any side effects. Some call it pure function. I think it had some other name too. So you can do this. You can swap the value of the return value of the function. Sorry, the calling of the function, you can swap it with the return value of the function. So instead of calculating this, you can just return the actual calculation when you have first calculated it, for example, by hand. And then we are doing the kind of hard-coded values, and then just doing some multiplication with the 4 and 5. So pretty good already, but the problem with that I'm having with this is that when I'm looking at this after a couple of years from now or a couple of months from now, there are a lot of magic numbers. So where does this 15 come from? Where does this 24 come from? How do I assert that all of these are correct? So always name as much your magic numbers as possible. So let's see how this did it. So human years -1. So if we have a truthy value for this, so if human years is more than 1, we return 16 plus 4 times human years. Okay. This looks a bit weird, but I'm sure it's correct because all the tests have passed. So 4 times human years. So if the human years is, for example, oh yeah, so this has subtracted 4 times 2. Oh yeah, now I see. So this is not the actual 15 or 15 plus 9. It's this is 15 minus 4, so you can multiply it with the number of years and get the same result. And this is 15 plus 9 minus 4 times 2, so you still add up to the same number. Clever, but again, brings up questions about these magic numbers that are kind of derived from other values. So you could have laid out how you got into this number by naming it correctly, but now these magic numbers just bring up really odd questions that what are these numbers and how did you come up with those, because these aren't even the numbers that you have been given by the assignment. Okay, this was the same as the first one, and then we have this I was looking for. So basically really procedural way of thinking about this. We just go through the loop in times, or human years times, and then add up to the kind of accumulator cat years and dog years, and then come up with an answer. This is the good thing about this, is that it's really clear what's going on here. It's this is a really dumbed down version of what's happening. You don't need any recursion, you don't need anything funky or funky calculations or caching or anything like that. You can just go through this line by line and understand what's happening. Really easy to follow. Oh, and then we have, well, this is basically the same, but with some code golfing with one character variable names, which is always a bit awkward to read afterwards. Well, of course, if you're trying to code golf and so do a smallest enough, like smallest possible solution for this assignment, then this is of course okay, which might have been the thing here, but never use one character variable names in your code. They're really hard to read afterwards. And then we have a while loop solution. So pretty much the same, but instead of doing the human years minus minus, which would have been kind of built in for the for loop, we are doing a while loop instead. While cont is smaller or equal to 3. Cont, what's the cont? cont is some magical thing that's where decrementing. Oh yeah, so this is an optimization for the loop. I see. So you only go through the loop 3 times. You go once through this 15 clause and once through this 9 clause, and then the final iteration of the loop just does the multiplication. So that's interesting. Interesting way of thinking about the problem. But the cont is is indeed a bit weird naming for the variable. I suppose continuation or something like that. It could have been just a loop or whatever. Okay, that's it for today. Thank you for watching. Please, it would mean a world to me if you would like or subscribe. But as always, happy coding!